Hi, my name is Rob, and this is a tech talk on getting started with automating ArcGIS Pro. In this session, I want to cover geoprocessing tools and how they represent a data processing framework within ArcGIS Pro. I want to cover different ways of executing geoprocessing tools in ArcGIS Pro, getting started with Arcpy and executing geoprocessing tools from Python using Arcpy function calls. I want to cover automating ArcGIS from Visual Studio Code, that is, utilizing Arcpy in custom Python scripts in an external or standalone IDE, an integrated development environment, in this case, Visual Studio Code. And I want to briefly finish on using AI as a learning aid in getting started with Arcpy. So, within ArcGIS Pro, on the Analysis ribbon, we have our Tools button, and in here on the Toolboxes tab, it lists all the system Arc toolboxes within ArcGIS Pro. Now, the amount of tools in modern versions of ArcGIS is vast, but in this session, I want to cover some popular ones and some old favorites. For instance, in the Analysis Arc toolbox, the Clip tool here. There's not an example later on in the session, but I also want to mention another old favorite, Buffer, which many people will be familiar with, and also in data management tools in here. People who've done a lot of Arcpy will be familiar with writing arcpy.management.something. That means you're utilizing the data management Arc toolbox of ArcGIS Pro. And in here we've got a couple of old favorites in the layers and table views tool set, and there they are: select layer by attribute and select layer by location. And those two are so famous they even have their own buttons on the map ribbon there. Select by attributes basically being a SQL query on a layer, and select by location is about selecting features based on proximity to features in another layer. So if we take a quick look at a tool, picking on Clip. So there we see on this little mouse over help thing, the important thing to note is that each and every one of these tools follows a geoprocessing framework, in that they all represent a function or method in dev speak. Or to explain as an analogy, think of them as a recipe. They all take inputs, they perform processing, they do something clever internally, and then produce an output. So you've got your ingredients, your input. It cooks you up the recipe, and then it serves out something nice in the output there. And each geoprocessing tool has its own equivalent function call in Arcpy. For example, for Clip, it is arcpy.analysis.clip. So if we take a look at the type, the Python type of arcpy.analysis.clip here in the Python window at the bottom, we see that it's a function. Yeah, the equivalent Arcpy function for this geoprocessing tool, Clip. And then Arcpy Analysis itself, you reference it by the module. So you say Arcpy module name, function name. And that's how these function calls work in Arcpy. And you'll also notice that the module name matches the Arc toolbox as part of all the system tools. Okay. To work seamlessly and consistently within the ArcGIS Geoprocessing Framework, these tools they have consistent properties, they have consistent things about them that they all share. Focusing on, they have the input direction parameters, obviously the layer in the case of Clip that you pass in that you want to be clipped. They of course have their internal logic. In a custom geoprocessing tool, this is a script or an ArcGIS model. And then you can set output parameters on them, okay? And you particularly want to do this for a custom geoprocessing tool you want to reuse. is set the output parameters so that, say, for instance, you use it in an ArcGIS model, the next stage in the process can get its hands on the output. As we see here, when you're writing a custom script, a geoprocessing tool, you can create one which has no parameters. It can just have its internal logic. But really, for best practice, if you're writing reusable tools or tools you want to share, you need to give them parameters. There's also metadata help. Whenever I write a custom geoprocessing tool, I put some help in the metadata, which is useful not only for other users, but for my future self. And the input parameter validation script. Metadata and help, and the input parameter validation script, they're beyond the scope of this introductory session. Okay, but in the next session, we go over how to build a geoprocessing tool with all these on them. But for now, let's just focus on the concepts and then we'll get into some coding. Key thing, looking at the basics and the concepts, is that all ArcGIS geoprocessing tool parameters fit a set schema and typing model, okay? You can give the parameters you pass into tools and then take out again specific ArcGIS types. And there are simple types such as numeric types and strings. And then there are built-in types you can pass in your Arc object, your feature layer, okay? Arcpy.mp.feature layer, the layer object. You can pass those in. And you can also use ArcGIS Pro GUI types, for instance, a map. I once wrote a publishing tool where you had a pull down and you could pick a map within the project and then choose some other options and it would automatically publish that map to ArcGIS Enterprise. There are other types, but the thing to note is all these geoprocessing tools share the same schema and typing model for exchanging information and sharing parameters, okay? And another thing to note, as well as single values, so you can have a single string, single feature layer, you've got multi-value array list support. So for instance, you could pass in multi-value, a list of feature layers into your script and then loop through them and do processing on each in a sequence. Taking the example of the clip tool, if I go back to that in the geoprocessing pane and let's open up the help. That takes you to the help web page here, and it discusses the inputs, processing, all the nice things that the tool does with diagrams there. And then we get to the parameters, and here we see we have the dialog parameters, which explain how the parameters are presented when running the tool as an end user in the geoprocessing pane. And then the Python parameters, which show the tool equivalent as a function call in Arcpy, with the parameter expressed by its variable name, which you would use if you were passing them in, expressing them literally in code. And I repeat, each system geoprocessing tool has its own equivalent Arcpy function or method, okay? If we take a quick look here, we see obviously the three properties for clip. You've got the input features, okay, and then the clip features. That's what you're sort of going to cut. The input, you're going to cut these by the clipping features, and then you pass in a path to the data set you want created. These says type of feature class, but it's actually a string path. And often Arcpy, behind the scenes, can convert strings into its own types under the hood, which can be useful, can not be useful in some cases. We'll come on to that a bit later. And there we see, if we look at the Python parameters, the data types are identical, okay? Whoops. Whether you run it from the geoprocessing pane or you run it using the Python function in code, it's all the same data typing model. Quick look at the properties. So if we look at parameters here, see what they actually look like on the tool, you'll notice the data type. That's what I'm talking about. The data type says feature layer, feature layer. You can express these as string paths, as well, or strings which identify layers in an open map. Yeah, but those are the types you want to pass in, and then it says whether it's mandatory or optional. Okay, and then obviously the direction. So we've got a direction of output, and that's most clear. We'll pull this into Model Builder in a little while and explain that a bit better for how these parameters look. To look at it in Model Builder is the best way of describing it for a beginner. And if we look at select by location, so we notice we've got a required input parameter. It's an input, but it's also an output on clip there. If we look at select layer by, where's data management gone? Select layer by location. Let's have a look at the help on this here. Takes a lot more arguments. And it has derived outputs here. There's 3 derived outputs there on select layer by location. So you've got the output layer of view, multi-value parameter. I think you can put more than one layer in, so it gives you the out layers of views, and a count of selected records. So you can have one output, you can have several outputs. Again, we'll have a look at what these functions, what these tools look like in Model Builder to explain, or how the input and output parameters visually, to explain it a bit easier in a little while. Okay, so in fact let's do that now. Let's go in, let's open up a new model, and one I prepared earlier, if we take a look, it's a clip I prepared earlier. So we say that we see the clip tool, you've got the inputs for what you want to clip, and then what you're going to clip it by. So what you want to clip is this feature class, what you're going to clip it by, and then we see our output, which is also an input, weirdly for clip. And then if we say select layer by location, let's just move it down here, we'll see we have 3 outputs here. Okay, so you've got one output, which is also an input for clip, and then you've got the 3 outputs on select layer by location, and showing that visually does help to explain it a bit better, I think. When you work with parameters, your own custom tools, it's not in this session, it's in the next session I cover that. It's really simple because there's 2 methods in Arcpy. There's arcpy.getParameter and arcpy.setParameter, or there's set parameter as text, get parameter as text as well. Let's close Model Builder. I don't want to go off on too much of a tangent with that. Let's use the clip tool to do a clip of some data we got on screen. What we got on screen is a 1 kilometer buffer of the center of a power station. So we've got some environmental data here. Got some, what's that, the blue we've got there. Priority habitats. Okay, so we'll clip out. Well, let's pretend we're actually working, and we want to find out which priority habitats. Our manager's asked us which priority habitats intersect a 1,000-meter buffer of the center of this nuclear power station. Okay, so we say buffer there. So we're going to clip this by this, and that's our output feature data set. So we see this has allowed us, this pull down has allowed us to choose layers from an open map, which is a very useful feature. So we'll run this now using the default output path there. Okay, and it's run through, and we get a green banner at the top here, which means it was successful. And then I'm just going to select all the layers using Shift, and I'll use the space bar, which toggles layers on and off. I find that a useful feature in ArcGIS Pro. I'm just going to switch on the output and the buffer and put these background maps back on. It still looks a bit cluttered. I'm going to just switch these to black and white using this layer blend luminosity, something I quite like. So I can switch color background mapping to black and white easily. Okay, so this is the output of that clip operation. And we can see that it's worked successfully. It's clipped out the priority habitats that are within that buffer. Let's copy this as a Python command using this. In the geoprocessing pane, we got copy Python command, and let's put it in the Python window. And this is going to show us the exact same function call with the same inputs. Okay, so there we go. We got arcpy.analysis.clip, and for the in features, it's just expressing. It says the type is layer, feature layer in the help, but it's just expressing that as a string because it can identify this layer name as a layer in an open map we've got here. Okay, the ArcGIS Pro IntelliSense is just cluttering up the view and making my machine go slowly, so we just have to wait for that for a second. So there we see we've got the equivalent function call, and yet we've got, even though it says feature class, feature layers, you express them as strings, and then under the hood, Arcpy will notice that that is an open layer object, yeah, in the current map, and it will run those in as layers, and it will produce the output feature class to here. So we can put a 2 on the end of that there, just tweak the output slightly, IntelliSense getting in the way again, and then let's run it again. Okay, and we've basically got the same operation duplicated with 2 on the end. Let's have a look at the history, and we can see these two clipping operations. These two at the top are the ones I've just run. So whether I run it from the geoprocessing pane or I run it from Arcpy, it's the same thing in essence as far as ArcGIS is concerned, and it puts the two history items there. Just another thing to note, basics of running these function calls, so as well as them being able to sometimes pass strings as outputs. Another thing to mention, if I go through my history here, you don't have to explicitly specify when you use it in Python, you don't have to explicitly specify the parameter variable names. You can just put the arguments comma separated. Obviously, make sure you keep them in the right order. So in features, clip features, output, and it will run that happily as well. What you can't do is when you start stating, if you start using the variable name equals as passing an argument into any Python function, this is a Python thing, not just an ArcPy thing, is once you start doing it for every subsequent argument, you have to keep doing it, okay? Or you get this positional argument follows keyword argument error in Python. As a general rule, I tend to, for mandatory inputs with functions I'm familiar with, I tend to not explicitly state them. But for any optionals or any outputs, I tend to explicitly state them. Okay, so for the inputs, it's obviously you're the input, you're what I want to click by, and then if my IntelliSense would get out of the way, and then the out feature class. That's how I tend to work for any optionals or non-mandatories. Sorry, for any outputs, I mean. For any outputs or any optional parameters, I tend to state them. But you can work however you want, as long as you don't start putting keyword arguments before positional arguments. Yeah. Okay. Let's try. Let's create another duplicate. I could overwrite outputs, but I'm going to create another one. This time I'm going to pass the result of this clip operation into a variable, because you could be forgiven for thinking that the type of output for this function, is feature class or file. Says there, but you'd be more commonly feature class. You could think it's that. It's a type of feature class. However, let's have a look at the result first. So another duplicate, and then let's say So we say type clip result. And it's a type of, it's not a type of feature class, or a string, a path to a feature class. It is a type of ArcObjects result. Okay, so not a feature class, so you've got to be cautious of saying, you're assuming clip result equals analysis clip, and that's a feature class. It's not. It's a type of ArcObjects result. In Python, there's a method called the dir method, which gives you all the types and members on any object in Python. Okay, and then we say dir, and that's given us all of these types and members, all of these methods and properties, which this clip result, this ArcObjects result has. And we see in here, there's one of a great importance to this session, which is the getOutput method. Okay, we can also see in here, we've got lots of methods with underscores. Oh, note, the methods with underscores, Python historically has not had access modifiers such as public, private, etc. So as a naming convention, underscores indicate that a method is for internal use, and so it shouldn't be called. So you don't really want to be doing stuff like this. You don't want to be calling these. You want to leave them alone. Now, whoever wrote ArcObjects result put these in there, and they're for internal usage. But you, of course, can call the public ones, which don't have an underscore, and we're going to say clipped equals clip result dot get output 0, and that 0 means the first output. So I wish I left that model open now, but we saw when we pulled it into Model Builder, there was one output. You get the outputs from a 0 based index, so it starts from 0. So the equivalent for select layer by location would be to get the out layer or view, you'd say get output 0. You'd say get output 1 for this and get output 2 for this. Okay, let's just show it on screen. So clipped equals clip result dot get output 0. Okay, and then let's see what the value for clipped is. And there we get our string to our output feature class. Okay, so that is the proper output for the tool that you would pass to the next stage in the process. Okay, if you're running several tools one after each other. And let's just have a look. The type, and it is a str. It's not a feature class. The feature class type is, this is the thing about ArcGIS types. You think, oh, what type is it? It's a feature class. But no, it's often in Python, that type is a string. Okay, it's expressed as a string, a path to a feature class. Okay. So you can execute the tools from the geoprocessing pane, the Python window, and from Model Builder. If we just get another model up, and then we can drag from our history there, and we can execute this from Model Builder. It should overwrite the output. Okay, and it's run that fine. It hasn't added it to history because this isn't a saved model. Okay, so there's nothing it can record it in history under. But if we see we see there that it's run through fine, and it's overwritten the result there. Let's get rid of all these from the map and move on to the next bit. Okay, if you want to get started with geoprocessing in ArcGIS Pro, it's really important to go in here and have a look at geoprocessing options. Familiarize yourselves with these, try them on and off. A particular pet hate of mine is the display data paths as shortened names. I'm really not a fan of it. So yeah, so it's got rid of the full path, and you have to click into that to get it. I don't like that. I like it just to show me the full path, and then I just use the end key if it's a particularly long path. But You might like that option. It's entirely up to you. Important to familiarize yourself. That's the key point. Try them. Another one is open messages window automatically. You might have noticed it is doing that when I'm running tools. That's another one that I like. Something else that is of key importance, hugely important in Arcpy in general, but definitely for this session before we want to start using Visual Studio Code, is if we go in Package Manager here, used to be called Python, it's now Package Manager, and if we check out the active environment on the top right here, and note this path here. This path is a fundamental configuration you need to provide in order to automate ArcGIS in an IDE such as Visual Studio Code, which I will come on to in a bit. The default Python environment contains all the libraries and modules which come installed as default with ArcGIS Pro, whether they are Esri, such as Arcpy, or third-party, such as OpenPyXL. That's a useful one for automating Excel. You see we've got Babel here. So Arcpy, it doesn't only come with its own module for running these geoprocessing tools, you get dozens and dozens of other modules as well installed by default as part of your the default Python environment, okay? And this path is very useful. Well, it's very important, rather. You have to use this to tell Visual Studio Code where to look to automate Arcpy in the IDE, okay? Let's go back in to our map and do a bit more work. So what I think I'll do now is I'll change out the background. I'm going to have a look at this data set, HS2 route. HS2, high-speed railway, I think it's currently under construction as I record this in late 2024. This is phase 1 going from London to Birmingham. And yeah, we're going to do some basic analysis, some basic real-world day-to-day analysis, okay. I'm going to switch on this ancient woodland layer. And I should also say, once we've done this basic real-world analysis, we're going to move it out into a script in Visual Studio Code. So, we're looking at UK ancient woodland map data. If I zoom in, we can actually see it. Okay, there we go. We've got some ancient woodlands with a high-speed rail line, which is proposed, currently in construction, overlaid on top. If we use the bookmark for Burton Green, we can see here that we've got some bits of the wood which intersect the railway line. Oh dear, so they might need to make with these trees, these ancient woodlands might have to make way for this stretch of railway line. We can also see, if we have a look at this Great Missenden bookmark and zoom in a bit, we can see that there are tunneled sections. So any analysis we might want to do, if we're going to answer the real world question, find me all the ancient woodlands which are going to be affected by the railway line, well, anything that's on top of a tunnel we don't really care about, okay. So that's an important thing to note before we do this analysis. Another thing to note, I've got this layer in twice. That's just basically to show the rendering of it easier for these sections which are tunneled and not. When I'm zoomed out, it's like a blue line with a single rendering, and then when zoomed in beyond 1 to 25,000, it's got a unique values renderer, so we can see tunneled sections. So, basic demo, we want to find how many woodlands of each type, ancient or replanted, touch the route line or are within 100 meters of it, ignoring tunnels. And luckily, I've got these examples in my geoprocessing history here. So the first stage is we want to select by attribute the HS2 route so that we are ignoring tunnels. So we say, using the select layer by attribute, we want to select HS2 route phase 1, where design type does not contain the text tunnel. So type not like tunnel. We'll run this. Okay, that's run through fine, and then let's have a look in our selection tab, and we've got 256 stretches of the track which are not tunneled sections. Okay, quite a lot of tunnels near London. One thing to note here with selection sets before I go any further, when you've got a selection on a layer, it's called a selection set of 256 currently on HS2 phase 1. When you pass that in, a layer into a geoprocessing tool, when it has a selection set on it, note that by default, and it's the same in Python, it will ignore everything else in the layer. It will only focus on selected rows. And that's something very important with using these geoprocessing tools, and it has caught out a few people a few times. Okay. The next bit, in my analysis to try and find the bits of woodland affected by this route, select layer by location. And this is really the clever bit. I'm going to say for my input features the ancient woodland, and I want the woods which intersect the route line using only the selected records, and I also want a short distance. I don't want just touching, I want and close to, so 100 meters of as well. So there we go. So run that through. It takes it a bit longer. There's quite a lot of maths involved in that one. And that's run through fine, and we can see in our selection here now we've got 38 woodlands affected by non-tunneled bits. Let's open the attribute table, filter it to just show selected, and let's go and have a look at one example. And yeah, oh dear, that's yeah, old ancient woodlands on the route there, so some of those trees might have to make way. The next bit, we didn't have to do the next bit. We could just pass this ancient woodland layer into the final stage, which is going to build us some statistics. But sometimes you want to copy your outputs for people. People want to see the actual layer as an output. So we're just going to copy that selection set on ancient woodland out as a layer. And this will show you how a geoprocessing tool, again, by default only cares about selected records. So if we say copy features, the next bit, and we're going to produce this feature class using just those selected records. So run that. And let's clear that selection down, and then it's added that to the map there, just that selection. So I'll switch the main ancient woodland dataset off. So now I can only see on screen the woodlands which meet that criteria. The final bit is I want some counts by type. We've got ancient woodland there, and I think it's called replanted woodland in like the sort of lighter green there. The final stage then is to give us some statistics, because often people don't want to just know the count, they want to know the count of which type of record. So it often becomes a bit more complicated. So let's just run this final stage, and there we go, very fast. And this is the final answer to our very, very simple and basic analysis. So 30 ancient and semi-natural woodlands are on or very close to the route, ignoring tunnels, and eight ancient replanted woodlands. So those are our answers. Quite often, working with ArcGIS, doing analysis work, you find yourself having to repeat analysis like this again and again and again. Okay, and it can be really, really useful to script it. Okay, in the Python window, it's great for, if you want to just if you just want to find stuff out and try stuff, and you want to find out stuff about the layers in your map that you've got open and things. But the real power of Arcpy comes when you start writing your own scripts using an IDE. Okay, and there's a few IDEs about. Historically, PyScripts are going way back with ArcMap, but since ArcGIS Pro in Python 3, I've always used Visual Studio Code, and it seems now that this is taking over as the most popular. For the next part, you need to have downloaded and installed Visual Studio Code and installed the Python extensions that we've got here. Okay. I'm not going to demo this. There's lots of help out there for getting started for downloading Visual Studio Code and getting the extensions in there. So once you've got it downloaded and installed with Visual Studio Code open, I'm going to choose a folder. Let's just choose a folder to work in. I've got this code demo 2 folder, empty folder, my workspace to work in. And the next stage is we need to hook up that path in the package manager in ArcGIS Pro into Visual Studio Code, because Visual Studio Code, when you first download and install it, it doesn't know where to look to run Arcpy. So let's just start with a new file. So we say File, New File, and we'll say Python file, and then we'll say File Save As, and I'm just going to call it, I don't want to save it there, I'm just going to call it demo 1, 2, 3. Okay, and let's say import Arcpy, and we've got yellow text underneath. It doesn't recognize it. Oh dear. So we need to hook up that Python interpreter that we looked at in ArcGIS Pro to Visual Studio Code. So if we go F1, okay, use the F1 key to bring up this this search within Visual Studio Code, and we say user settings, and it says preferences, open user settings.json. Okay, and we can see here that what we haven't got, what I've put an underscore on it to render it meaningless, and I need to undo that. We've got Python default interpreter path, and we've got that path from the package manager in ArcGIS Pro, and then there's a Python executable in that folder, and that's what you need to point Visual Studio Code at. So I'm going to get rid of that underscore there and just put an underscore on here, which was another environment I was using. So I save my settings.json there, and then close. Oh, just one thing before I close, actually. Another thing to note, if you're just getting started, is with these launch configurations, okay, if you put a launch configuration in here, have your console as internal console, because if that means basically that it's going to put any print statements out to this debug console here. If you, I think the default is it puts them to the terminal, which has been frustrating certainly for me in the past. So console, internal console, to make it print out to the debug console. Okay, to check that this has worked, we'll go back to our demo file, and yeah, that's looking better. I'm going to save that. Now that warning message underneath Arcpy has gone. I'm also just going to put in a statement which grabs the Arcpy version as well, just so that when we run this, we've got a print statement after the Arcpy call, so we know that it's worked. Okay, so we say run, and it takes it a few seconds because Arcpy is quite big, and it should print out our version of Arcpy, which will mean success. Okay, so we've managed to set up Visual Studio Code so we can automate ArcGIS. Okay, so the next bit is to get these commands from the geoprocessing history, and let's copy those, and then we'll put them into our script, and we'll try and reproduce the exact same thing from a script in VS Code. So we paste them in. Unfortunately, they're in the opposite order. So let's just reverse that quickly. And then, so we get them in the order that they were, in logical processing order. Okay. And then if we take a look at some of these inputs, we see that they are only relevant in the context of this map here, this ArcGIS Pro map. They're only relevant in the context of this ArcGIS Pro session, so we need to substitute these in with valid data paths or layer objects. Okay, so what I'm going to do, and one way I often, excuse me, like to work is for anything I need to fix or replace, and this is more beneficial in sort of larger scripts, but to demonstrate it, is I like to purposefully break anything that I need to change, and then that shows up down below in problems here, and I can quickly refer back to anything that I need to fix, which is a nice useful feature of Visual Studio Code. So all these question marks, they need to be updated and replaced with different data sources, with strings or layer objects. So if we have a look back in ArcGIS Pro, we need the data source of this, not its layer name in this project. So if we go properties, we see our URL here. That's our data source, and we can see that it's an ArcGIS Online feature service, openly available, that I'm using for this HS2 route line. So that's one way of getting the data source. There is a keyboard shortcut, Control-Alt-P, which I found the other day, which never works for me when I try it. But let's try it again. So if you click a layer and you go Control-Alt-P, this is get item path, I think, but it doesn't actually give you the data path. It gives you the internal path within the ArcMap document, the sim path. However, I do have a useful Python snippet somewhere in the GP history here, which gets the current ArcGIS project and the active map, and then lists all the data sources. Okay, so you see, learning a little bit of Python can just help you out with sort of basic day-to-day trying to find the answers to stuff. So that's the HS2 data path. So we copy that, and then I say 2 source equals, and then put that in there. And one I prepared earlier. We need the ancient woodland source as well. Okay, so we paste that one in there as well. So we've got our input parameters here, our strings, and we can then start feeding these into the methods. But it's important to discuss at this stage the concept of layer objects. Okay, in ArcGIS Pro, when we ran these tools, it used ready-made layer objects from the contents pane of an open map. But in script, we need to set variables as these layer objects in order to use them and pass them to the next method in the processing sequence. You also need to get them as layer objects so that you can use methods on a layer object, okay? So that you can set parameters on a layer object, such as a filter or definition query. Okay, so it's really important when you use your scripts not to really use strings as layer objects, but you want as layers, but you want to get layer objects themselves in Arcpy. Okay, and there's a couple of ways. In this simple scenario of doing this, we can use arcpy.management.makeFeatureLayer to generate a layer object itself and then pass that in to the Arcpy function call, or you can get the layer object from the geoprocessing result, the ArcObjects result, and that get output method. Okay, we need 2 feature layers, one for the HS2 route and one for ancient woodland, so we'll use both ways. For the select by attribute call, let's use the get output method on the geoprocessing result. I'm going to remove the invert where clause as well, so I'll just replace this with something I prepared earlier. And we can see I've updated the in-layer view to that HS2 source, okay? So I'm going to use the GP result to get the layer object for this selection. We're going to select the type is not like tunnel, remember, that's what that is about. And Arcpy will automatically pass this string path as a layer object internally and wrap it as a layer and present it to us on the output, which is going to be this root layer object, okay? So that's the first bit. And then I'm going to put a nice print statement for myself here so I can see it's actually worked properly, which is useful. I'll put a breakpoint on both of those. The next bit, I'm going to use the other way. I'm going to make a feature layer up front, okay? I'm going to use arcpy.management.featureLayer. So, for the select layer by location, For the ancient woodland layer I want to pass in, I'm going to create a layer object here using arcpy.management.featureLayer. That gives a GP result. I immediately call getOutput on that GP result at index 0, or the first output, and that gives me ancient woodland, this URL, wrapped as a layer object, okay? And I then pass that into the select layer by location. So rather than type in these changes for speed, I'm just going to copy and paste a snippet I prepared earlier. So there we can see that I've set as the input layer as the ancient woodland layer that I've made in the previous function call. And what it will do is it will perform a selection on this layer. So after this method has run, this layer should have a selection set on it of the ancient woodlands which intersect that HS2 route, yeah, at a distance of 100 meters, and the route layer will not have tunnels selected as well. So those will be ignored, just like it was in the front end. Another thing I've done here, which is just thinking about how Arcpy, these functions work internally, is I've actually, as well as feed a layer in, I'm pulling a layer out by using getOutput as well, okay? Now what I would expect is that this layer passed in is the exact same object in memory as the layer I get out. But we'll see what happens there. And I'm going to add a couple of print statements after this, just for diagnostics and understanding. So, yeah. So there's a diagnostic there about the layer memory references using ID to have a look at the memory ID of the two objects I make. And then another print statement to compare the counts, yeah? Using Arcpy, let's just use a new line using an escape there. So that feed that statement down to the next line because it's a bit big on screen, wasn't it? And then what this one's going to do, it's going to print out the count on the layer I feed into the function and the count on the layer that it pushes out of the function as well. Selected features, and then hopefully when we get down here to copy features, I can then use my ancient woodland layer. It should have a selection set on it, which means it will only copy out selected features as a new feature class. I'm going to call that underscore code so that I can identify it. I'll just save the file as I go. Let's put a debug, couple of breakpoints there to use when we're debugging. And then the final bit, statistics, the input will now be this feature class with code on the end, okay. And in case anyone's interested, the arm there means raw string, and that allows you to represent single backslashes in paths. Without the R there, this syntax represents a character escape in Python, and the script will blow up when you run it. Okay, so that's what the R means. It means raw string, allows you to put single backslashes in paths. If you get rid of the R, you can use double backslashes, or you can use forward slash as a path separator. But anyway, with the R, with the single backslashes, you need the raw string there to make it work properly. Okay, so, and then the final bit, this output here, I'm going to call that code as well, so we can identify it, and then we don't need that optional parameter there. And I'll just put a final print statement at the end, so we can pray and hope that this script runs through. Okay, so let's run it. It'll automatically save when I start running it, and this should do the exact same thing in code that we've just done using those 4 geoprocessing tools manually. First part is the selecting bits of the HS2 route which are not tunnels. Okay, and then that has produced, and it's told us, yeah, The result type is a geoprocessing result, but the output object is a layer object. There we go. The next stage, I've generated a layer called Anwood layer using, and there we can see its types and members there. It's not a GP result, it's a layer. It has a definition query. It has stuff like is base map layer. Layer object using get output. And I'm going to pass that into this select layer by location call. I'm going to let it run through printing these out and copying the features. And it should only copy out what is selected, okay? So let's continue to run it through. Okay. And it's, so it's run through and it's copied some features out there. So if we go back into ArcGIS Pro, we should see this ancient woodland 100 meters ice intersecting phase 1 code. Let's have a look in the catalog pane. Refresh you. Yeah, there it is. And there we are. The exact same output as we got running it manually. Okay, and then finally, the statistics. Yeah, so it's run through finally. A couple of observations. The layer that we fed in, that we used make feature layer, it has a different memory address to the one we got from the geoprocessing result of select layer by location. So I think that's a bit weird. I would have thought that Arcpy behind the scenes would have just ran the selection on the same layer object, but maybe it's created a new layer object, not sure. And then, but whether it's the layer we pushed in or the layer we got out, the number of features selected is the same there. At 38, my print syntax isn't quite that clean, but I think we get the point. And then if we have a look at the summary statistics output here, let's refresh, excuse me, with the counts. Let's try it. There we go. Counts code. And it's exactly the same result. So, yeah, we've taken a bunch of steps we did manually in ArcGIS Pro, and we've put them out into a script. By automating ArcGIS Pro, therefore, using scripts, this gives you huge opportunities to increase your productivity. We could alter the input here. For the input for the root layer, we could change that to a different root layer, run the script through again with a few tweaks, and without needing to run these processes manually, you can get some results for ancient woodlands which are close to a different linear feature. Or, for instance, we could change this, the comparison layer, the ancient woodland, we could change that into a list. Add the priority habitats layer in there, or a different constraint, for example. Then add a for loop here, and loop through these in a list, and we could get results for the proximity of as many layers as we wanted. Yeah, with a few tweaks, obviously, for some hard-coded field names there, but we could, it lays the groundwork for building in a lot more functionality, for a lot more automation, and obviously a lot more capability than just running tools manually. There's also the possibility for bringing in other technologies and combining technologies. The installation of Python you get with ArcGIS Pro, it comes with a lot of third-party Python libraries built in. For instance, NumPy. There's also OpenPyXL for automating Excel. Yeah, so by combining technologies, it's very, very powerful, gives you a lot of opportunity. In the next tech talk of mine on getting started automating ArcGIS is how you would build upon this very, very basic script, yeah, and you would make it into a reusable custom geoprocessing tool. But before you could do that, well, let's talk about what's wrong with it, because it's very, very basic, very, very linear. There's no input parameters, we've just got hard coding here. There's no error handling. It needs some try except blocks for error handling. There's no flow control. There's no if statements or loops. There's no validation of any inputs. And there's no output parameters. If you wanted to make this sit this behind a custom geoprocessing tool, you need to use set parameter to set some outputs. And there's also no geoprocessing messages. The geoprocessing tools in ArcGIS Pro, some of them produce messages out to the console in ArcGIS Pro like this from the clip tool. That's not the print statement. That's not the print statement in ArcGIS Pro. What you need is you need to use arcpy.gp.add-message. There's also arcpy.gp.add-warning and add error as well. So you need some proper debugging statements for use in a geoprocessing tool. And of course, we would need to wrap this up in as an actual script tool, and then we could add metadata and help onto it and a tool validator script onto it as well. And that's what my next tech talk on this will focus on. Finally, let's look at how AI can help you as a learning aid when you are learning Arcpy. So I'm going to close this workspace. And I'm going to open this code demo 2 guff workspace. Okay. And basically, went to ChatGPT and asked it this question, okay, which is basically what I've done in this demo in a simplified term, is write a Python script to select features, then use those features to select intersecting features in another layer. Okay, and ChatGPT, it's so clever it comes up with a slightly different answer every time. But this, the first time I did it, is what it came back with. Okay. There we go. And so it's importing Arcpy, setting some layer variables, which I've obviously filled them out and changed them so that they work, okay, and tweaked them so that they work. It uses arcpy.env.workspace. Basically means you don't have to set the full paths of things. You just put the feature class name and it will understand it. Using arcpy.env.workspace, it will look for it in sort of your root. That's like your root workspace. Okay. And then it performs an expression, make feature layer, passing an expression in that actually puts a filter on the layer, a definition query. Not a selection, but it's near enough. And then it runs a make feature layer again on like the ancient woodlands layer on that one. Layer 2. Select layer by location and copy features to an output. Okay, let's see if it actually works. Get rid of these breakpoints and just let it run through. Okay, and it says intersecting features have been selected and saved. Okay, let's take a look in the catalog. We've got this temp. Okay, and there we go. So, well done. We didn't use the within 100 meters argument, did we? So it's not quite identical results, but it has worked. So well done, ChatGPT. However, the file itself, it has all the faults of the very basic file we've just produced, doesn't it? It's got no flow control, it's got no error handling or try except blocks. There's no validation of inputs, there's no parameters, but as a basic standalone script, it does work. So, ChatGPT, it can give you ideas, but beware it doesn't do more harm than good, because this is the old ArcMap syntax here. It's not even accessing the layer object as an object in the script, it's just passing it as a name to Arcpy. So Arcpy will recognize that as a layer name, and you can pass it on further down to other methods, but it's not great practice really. And then there's delete statements at the bottom to clean up. Yeah, of course, this will basically remove the layer object from RAM and remove a lock off of the data set. But if you start tweaking this as a beginner to Python and you've got Arcpy management delete statement in there, you've got to be very careful what you end up passing into that. But you have to say it is impressive initially. It is a very good learning tool for anyone wanting to learn Arcpy. It's not to say that the syntax will be up to date or correct, but it can point you in the right direction to the actual ArcGIS Pro functions, the actual geoprocessing tool that you need. Just one other thing to note, as I labour the point about accessing the correct types in your scripts. I've trapped here the result of that Arcpy make feature layer management. I've basically copied that script from ChatGPT and made some tweaks to this. Let's run this through to this breakpoint. And this is why you've got to be very careful as a beginner making assumptions. Arcpy, it will set you up to fail. So I'm saying X equals make feature layer. Great, that'll be a feature layer then. No, it won't. It's a result object. Okay, so you try and print a method, a member, a property of a layer object, and it says it doesn't exist. Okay, you get an error. But then in Python, and this is different to other languages, it lets you set a non-existent property. So then you can then just create definition query on that result object. And then we dir that, and we've got definition query added in, even though it didn't exist to start with. So you can add your own stuff to Python objects. There we go, but you've got to be careful. You mustn't start assuming that these Arcpy function calls return the actual objects that you're expecting as the output. They return a GP result, okay? Labouring the point. So there again, we've got the selection has worked, those 256 from earlier on HS2, and look at this here. It actually worked passing in the geoprocessing result as the select features argument of select layer by location. Okay, so you've got to be careful. So Arcpy will accept stuff it shouldn't really select. It should be saying, I want a layer object or a path to a data set. But no, it's fine. You can pass a geoprocessing result in, and you can pass a geoprocessing result into get count. And it's worked. And it's printed the selected count. But then, so you might start assuming that this X object is a layer. But again, labouring the point completely. If you try an actual method that's on a layer object, you get a big fat error, okay? So to access the actual types and members of the layer object, yeah, like get definition, you need to work with layer objects in code, okay? You need to use get output, and you need to get the actual feature layer object. Another thing though, it will even let you do stuff like describe this geoprocessing result. So Arcpy, you know, Arcpy can be so nice that it just leads to errors down the line. So it's even let me describe the geoprocessing result, and then it's printed, and the describe object is legitimate, like we've got the catalog path here. So it's worked, but you've got to always be thinking about using actual objects in code. Just some points there for how Arcpy can set you up to fail. It can let you pass a string constant as a parameter for a layer. It can let you pass a geoprocessing result as a parameter for a layer. And even stuff like describes let you pass a result, and the describe object is legitimate. But because of this versatility in Arcpy and accepting inputs to methods which are not strictly tight can just lead to buggy scripts if you're not careful. So yeah, it's impressive how AI, it can put somebody with no knowledge of Arcpy in the right direction, and it actually works once you've hooked up the inputs and outputs, okay? In my next video, I expand on the script produced earlier on. So that was this one here. I expand on this script produced earlier on and how you can turn it into a geoprocessing tool, adding all of the stuff I said that it needed, so that it fits into the ArcGIS Geoprocessing Framework. So, to summarize, the geoprocessing tools built into Pro, think of them as recipes. They all have the same properties and share the same schema and rules for parameters. They can be executed from the geoprocessing pane manually in the Python window or via Model Builder as part of a model. Each geoprocessing tool has its own equivalent function call in Arcpy. The function call returns a type of ArcObjects result, which has a getOutput method you can use to retrieve the derived output parameters. And you can script the usage of geoprocessing tools outside ArcGIS Pro in an IDE such as Visual Studio Code, providing you tell VS Code where the Python interpreter is first. And AI, it's a useful tool for getting ideas about what Arcpy methods can be used to achieve a task, but it is no substitute for actually learning and understanding Arcpy. Well, thank you for watching, if you still are, perhaps. My name's Rob Hooley, and I am an ArcGIS automation specialist who has been automating ArcGIS for many years, beginning in 2011 when I first got to grips with Arcpy, but even before that I used to automate ArcMap using VBA. And this session, it's just the beginning really of some ideas for getting you started with Arcpy and some important tidbits of information. In the next video, I discuss how the simple script produced in this video can be molded into a reusable custom geoprocessing tool with the improvements suggested, such as error handling, better flow control, etc., and demonstrating how you can write your own tools which seamlessly fit into the ArcGIS Geoprocessing Framework. No one knows everything about a vast technology such as the ArcGIS system, so please get your comments in if you found this tech talk useful, but also if you have your own insights on the topics discussed. I'll add links in the description for the project package and scripts involved in this demo, just in case anyone actually wants to access them. Thanks for watching, and bye for now.